everyone, welcome back to my math teaching online today. Um, Today is a big day, the historical event today. Listening to the President Joe Biden's speech today, I felt deeply in my heart. Um, um, it's a mixed feeling for the America because we went through so much these days. However, um, his speech is such inspirational, and I felt very happy for America and very hopeful and promising. Anyway, because today is a happy day, so I'm happy to uh, talk about the lesson today, and I cannot avoid sharing my feeling to um, my audience. Anyway, let me read the question out loud to you and see how we can solve this problem. Find the volume of a solid whose cross-section perpendicular to the y-axis are isosceles right triangle with its hypotenuse in xy plane. So on the board, I show you the diagram. This is the x-axis, this is the y-axis, and we have the straight line x equal 3 because the this line is go through the x equal 3. So it has the equation x equal 3. This is a straight line. And we have a function y equals square root of x given. So the question asks us to generate revolving the region along the y-axis. However, the cross-sectional area in this question is no longer a disk like in other previous question we did. But this is a little bit different, which is the cross-section is a triangle, right triangle, with the two sides equal isosceles. So the side equal the side. So I draw this diagram to demonstrate that you can see that this is the hypotenuse of the triangle of the right triangle, and this hypotenuse perpendicular to the y-axis, right? This hypotenuse. So imagine we cut through the region by these slides, and these slides are not the fixed line, they're not the same size, but they're changing according to the shape of the function, right? So you can see that at the bottom here, this is the triangle getting bigger and bigger. So here is a small triangle, and then it gets bigger and bigger at the bottom. And the reason the shape is changing because it's shaped along with the function. And therefore, we're not dealing with a fixed number, but we're dealing with the rate of change. And that's why we have to use calculus, which is the rate of change. Now, so think about this for a moment. How are we going to deal with this question? How are we going to do it? So first, let's make observation. To generate this function, this cross-sectional area along the y-axis, we have to know the boundary. We have to know what the number we generate from 0 to what. So if x equals 3, we substitute to find the y coordinate here, right? So if our x equals 3, our y equals square root 3. So that is the coordinate of this y here. So now we know we'll generate the volume between 0 and square root 3. So that's the first thing we do. Second step, we have to, because we generate about the y-axis, So we have to find the function in term, the function of x, right, in term of y. And the function of x in term of y is a reverse function. So second step, we're going to find reverse function. Reverse function. So our reverse function is, so we have this function, right? Y equals square root of x. So in terms of the reverse function, we have to solve for x in terms of y. So to solve for x in terms of y, we'll square both sides, right? So that the x here will cancel, the power here cancel with the root. We got x in terms of y, so x equals y squared. So now this is the reverse function. Reverse function f of y in terms of x, right? F of y. So that is the first step we should do. Secondly, any volume would be equal the cross-sectional area times width is height to form a three-dimensional shape, which is the form of volume. But our cross-sectional here is not a circle, it's a triangle. So we have to find, so step 3, we have to find the area, right? The area of a cross-sectional shape. And the shape here is not a disc like we did before, but it's a triangle, right? And it's a right triangle, right isosceles triangle. The side equal the side, okay? So I mark here the side equal the side. So imagine you slide through the surface perpendicular to the y-axis with this triangle shape, right? And this triangle changing from small, getting bigger and bigger at the bottom, follow the curve, okay? So first we have to find the area. And how do we find the area? The area of the triangle equal, so any area of the triangle, right triangle, or any angle equal base times height divided by 2. That's the formula we know, right? So base times height divided by 2. So our task is to find the height here of this right triangle and this base here. Now, fortunately for us, this height here equals this base because this is the isosceles right triangle. From the question is stated, right? So as long as we know the base, then we know the height. But how do we know the height here or the base here? And to find this, we have to relate it to something. I'm going to give you a hint, right? We're going to find the hypotenuse first. Then from the hypotenuse here, we're going to connect to find the base. Keep in mind that when we're doing that, keep in mind that the hypotenuse here, as well as the base here, are not a fixed number. They are changing. They are the rate of change according to the function. So the first hypotenuse smaller, bigger, and get bigger, right? But how do we find the hypotenuse in terms of the function? Because we cannot find the fixed number. We have to find in terms of the function. So look at the hypotenuse of this triangle from this coordinate to this coordinate. So when you want to find the length of any straight line like this, right? This hypotenuse here, you use the end point, subtract the beginning point. So we use this coordinate, subtract this coordinate to get this hypotenuse here. The same like this one, use this coordinate, subtract this coordinate. This coordinate, subtract this coordinate to get the length of it, the length of the hypotenuse, right? I mark the HPP is the hypotenuse. But we have to find it in terms of the function, right? Which is this function, subtract this function. And what is this function? This function is x equal 3. And this function is x equal y squared. So we use this function, subtract this function. So the hypotenuse will be equal 3, right? This function is 3 minus y squared. That is the hypotenuse. That is the length of the hypotenuse in terms of the function, not in terms of a fixed number, but in terms of the function. So now, based on this, we're going to look for the base. And how do we going to find the base here? Now remember, because this length equals this length, so we know each angle here is 45 degrees. So if we relate it to the ratio of the angle, we might be able to find the base here. So let's look at this angle here, right? Let's look at this angle here for me. Now, opposite with this angle is this base length. So we use sine of 45 degrees, and this angle is 45 degrees. So we're going to say sine 45 degrees. And we know the ratio of the sine of 45 degrees, which is 1 over square root 2. 1 over square root 2. And this sine of this angle equal opposite divided by hypotenuse. So we're going to say this is equal opposite, right? And our opposite is actually turned out to be the base of the right triangle here. So opposite over hypotenuse. Or I can also say the base, right? Opposite is the same like the base over hypotenuse. So now we have the ratio 1 over square root 2 equal the base over hypotenuse. And I'm going to substitute the hypotenuse here by this equation because this is equal, right? Hypotenuse equal 3 minus y squared. So I'm going to substitute it. By doing related ratio like this, we'll be able to find out the base of this triangle. So if we do cross multiply, right? This time that equal this time this. So 3 minus y squared times with 1 is just the same. Will be equal the base. And I'm going to put the base, just the b letter for now, okay? B times with square root 2, right? B times square root 2. So for b, we will divide both sides by square root 2. And therefore this cancel. So we left with the b will be equal to this number, right? B equal to this number. So now we know the b's in terms of the function. And b here is the base, right? So now we'll be able to find the area of this cross-sectional area in terms of this function. So we will say area, cross-sectional area, right? Cross-sectional area equal base times height, and our base is 3 minus y squared divided by square root 2 times with height, and the height is the same, right? And all of this will divide it by 2. That's the formula of the area of the triangle. Okay, so now I'm going to multiply them through. Actually, I can combine them, right, in terms of one function, which is the same like this, right? Two bracket the same like power 2 over now so this time this the same like this, and this time this will give us, okay, let me see, area equal the base equal our base equal 3 minus y square over square root 2. So base times height, that's right, divided by 2 is the area. So we're going to simplify this. So this time with the top will result in this one, right? The bracket like that. This time with that will result in 2. Remember, we have to divide by 2, which down here we can bring them to multiply. So we get area equal 3 minus y square on of the square over 4. That's the area. So now we know the cross-sectional area like this. All what we do is using the iteration technique, revolving the region around the y-axis by iteration technique. So our volume will be equal integrate from 0 to square root 3. And we're going to put the cross-sectional area, which is this 1, 3 minus y square, 1 over 4. And I'm going to put 1 over 4 outside here, right? We can do that. And dy. So by doing this, we'll be able to generate the volume of this cross-sectional region, right, along the y-axis. So let me continue here. So I'm going to continue with that form. I'm going to integrate that, right? So our volume now will be equal 1 over 4. I want to expand the function first, okay? 0 square root 3. I'll expand this. And the power of this is like the formula a minus b on of the square will be equal to a square, which is 9, right? 3 square is 9. Minus 2 times a times b, 2 times 3 is 6. b is y square. And adding with y b square, which is y to the power 4. So I'm just expand the bracket, right? And dy. So now I'm going to do the integration, which is the antiderivative. So the antiderivative here is 1 over 4 outside. 9 will become 9y minus 6 divided by 3y to power 3, adding with 1 over 5 times y to power 5, and we'll generate it between 0 and square root 3. So volume will be equal 1 over 4, 9 times with square root 3, right? I substitute y here by square root 3 minus 6. Now let's divide it down. 6 divided by 3 is 2. Y here we substitute by square root 3 times to the power 3, right? Adding with 1 over 5. Y here will substitute by square root 3 again to the power 5 and minus 0. And why do I say minus 0? Remember, we have to subtract this, right? But if we substitute 0 in here, this term becomes 0. 0 substitute in here, this term becomes 0. They all become 0, so minus 0. So I'm going to have to continue to the next board. So let me continue up here. So I'm going to go up here, okay? From here, I'm going to go up there. So volume will be equal 1/4 times with 9 square root 3 minus 2. I'm going to turn this into square root 3 times square root 3 times because that's power 3, right? Adding with 1/5 square root 3 to the power 5, so 5 times square root 3 times square root 3 times square root 3 times square root 3 times square root 3, 5 times. 1, 2, 3, 4, 5, right? So I'm going to do it by long way instead of using the calculator. So we have 9 square root 3 minus, now this combined will be at the 3, right? Because square root 3 times square root 3 equals 3. So 3 times 2 is 6. So we have 6 square root 3. Adding this combined give us a 3. And we combine this one, give us another 3. And we left with this one, right? So 2 of them give us a 1, 3. 2 of this here give us another 3 and 1 left over. So we have 3 times 3 is 9. 9 square root 3, 1 left over 5. Yes. So let's work it out. 1/4 times with, now this is the like term, 9 square root 3 add 9 square root 3. So we add them, we get 18 square root 3 minus 6 square root 3. Oh, I cannot do that because this is 1/5. Cannot do that. Sorry. So what we're going to do? I'm going to make common denominator, right? So let's distribute this. This time that will be a 4 underneath here. This time that will be a 4 underneath here. And this time this will be a 20 underneath here, 4 times 5. So I get rid of this, right? I distribute it in here. So now we have 20 here and we have 4 here. So our common denominator will be 20, 4 times 5. So the top m times with 5, the bottom m times with 5, top m times with 5, bottom times with 5. So 9 times 5 is 45, square root 3 over 20 minus 6 times 5 is 30, square root 3 over 20, adding with 9 square root 3 over 20. And actually this shouldn't be here, right? It's gone because we distribute in there already. So now the on the like term, 45 minus 30 will be 15, right? 15 square root 3, adding with 9 square root 3 on of this over 20. So volume equal 15 square root 3 plus 9 will be 24 square root 3 divided by 20, reduce the low fraction, divide by 4. We got 6 on the top, square root 3, and the bottom divided by 4, we get 5. So that is the answer of our volume. Okay. So I hope that this is clear to you. Because this is a complicated question, so I'm going to give you a summary at the end, okay? So first, we draw the curve y equals square root of x. We draw the line x equals 3, right? These two curves will meet at this intersection, and we know this axis never changes, it's always equal 3, and therefore we substitute in the equation, we find this coordinate y here, if x equals 3, y equals square root 3. So we know that we have to generate from here to here, 0 to square root 3. Our cross-sectional area have a shape of the right triangle isosceles. This side equals this side. And the shape of the right triangle here is changing from small to big. It's not a fixed shape, but it's the rate of change according to this function. So to find the area of this cross-sectional area, we have to find in terms of the function. We're not going to find it in terms of the number, right? So how to find it in terms of function? We know that to find the hypotenuse, we have to subtract from this coordinate, subtract this coordinate to get the length from here to here. And this coordinate in terms of function is x equals 3. This coordinate in terms of function is x equals y squared, because we have to reverse the function if we want to generate along the y-axis. So we reverse the function, right? So this function is x equals y squared, and this function is x equals 3. So we say this subtract this, which is our hypotenuse equals 3 minus y squared, right? 3 minus y squared. So then after that, we find out the base here by using the ratio of 45-degree angle, which is 1 over square root 2 is the sine of 45 degree, and the sine equal opposite divided by hypotenuse, which is this length. So we pair square root 1 over square root 2 equal the base over the hypotenuse. And then we use that ratio, we find out the base length. So after we do cross multiply, we find the base length, then we put in the area formula. And the area formula is base times height, which is both the same, turn out this way, divided by 2. And our base will be 3 minus y squared, times with our height, which is the same, 3 minus y squared, right? Divided by 2. So divided by 2, but remember we have to divide it. Actually, after we find the ratio, we know that the square root 3 minus y squared over square root 2. So square root 2 times with square root 2 turn out 2. We have to divide by 2, so that is over 4. So after we find the area, we put in the integration, and we integrate using the dy and generate from 0 to square root 3. So we get the answer here is the volume in terms of exact value. So that is the lesson today we learned. So anyway, I hope you enjoy my video. It's a little bit complicated, but I will show you another question still related to volume of solid area. Volumes of a solid revolution. Okay, so I hope you enjoyed this video today, and stay tuned for our next video. Will be another interesting question. I'm going to post it here. However, before I go, let me remind you a little bit from my website. Please go to my website at mymathteaching.ca. If you don't want to support me by buying my courses online, you can learn free online education weekly. I will post my lesson plan weekly. So if you want to be curious or interested, let's go to my mymathteaching.ca, and I will post weekly lesson plan, except that maybe the exercise part and the whole lesson sometime might not be download the full thing. If you register for my full course, you get access to everything. But if you learn from my website here, you can follow it along, watch the video. If you don't want to do homework, that's fine. You can watch the video to understand about the topic. If you take the Math 12 calculus in the school, high school, or in the university when you have to take calculus, this lesson is powerful tools for you to understand this topic in a depth knowledge. So anyway, thanks for watching and bye for now.